Thank you everyone for joining us today. This is session 2 in our 3-part series around building an AI playbook in order to enable kind of success effectively across the enterprise. Today, we're going to specifically focus on how the platform component of that plays into your strategy and enables the specific outcomes that your organization is likely trying to undertake with AI. We'll start with the ideas, frankly, around the concept of where a hybrid approach likely lands in terms of the way that you tackle these particular infrastructure and platform challenges. First, we want to start out with the fact that we really view AI as a function of 3 key components across your organization. The first, and obviously incredibly critical one of those, is data. Data will play a massive role in the decisioning and placement, and frankly, the disposition of AI workloads and the efficacy of those workloads across these platforms. But we're going to focus primarily today on the middle or platform component of this ultimate strategy. When we say platform, we mean the combination, frankly, of the infrastructure layers, right? The network, compute, storage components that ultimately enable the business functionality from an infrastructure layer. But we also mean the software stacks and availability of those portable platforms and pipelines in support of the ability to deploy these and operationalize these workloads at scale. And then the last function is really kind of 3 parts, which we call cultural elements around AI. The first of those is, how does an organization think through, ideate, and govern the number of ideas around the potential for AI as it relates to your specific business? The second one is, how do we think through change management and enablement patterns, not only to help people understand what's possible, but ultimately to help them ingrain what we deploy into their everyday use and workflows. And then the part of culture that we're going to focus on today is, how do we orient our organization around a construct like experimentation? Traditionally, what we see in the enterprise IT space are that we make investments with very clear-cut ROIs, and we look for those particular payback periods and gauge success directly correlative to the investments that we've made. But in the AI realm, we know that over 80% of initial ideas don't necessarily make it out of the POV phase for organizations. So we have to get more comfortable with the fact that business value doesn't actually occur accretively until models are deployed and democratized across the organization. So a lot of the toil on the front end is really about, how do we embrace this culture and idea and investment strategy, fostering innovation through an experimentation landscape. It's important that we work off of kind of what a common definition of what hybrid AI architecture ultimately is. And this may feel a little on the nose or fairly similar to the work that we've been doing in infrastructure broadly over the last decade and a half. But ultimately, what we're talking about is a deeply interconnected ecosystem of cloud computing and cloud platforms and flexible resource pools tied to on-premise data centers that enable on-premise data infrastructure, secure connectivity, and advanced storage and processing through accelerated computing mechanisms. And ultimately, in many circumstances, the deployment of those models as close to the edge as humanly possible, so that we get improvements around latency and sensitivity and criticality of the workloads where the challenges actually exist. So why do we think that hybrid is a requirement, frankly, through this whole process? Well, it really breaks into kind of 3 things around how the enterprise is going to function in this space. So if we reduce the kind of concepts around the concentration in the CSP or cloud service provider space and the massive hype cycle around the build out of AI infrastructure for the purpose of being a service provider downstream, and we simply focus on the needs of how enterprises will likely adopt these types of capabilities, I think this becomes far more clear. The first is, we have a massive amount of growing demand, and no single point in the infrastructure ecosystem can actually meet the diverse needs that the enterprise ultimately brings to bear in order to be successful in this space. So in order to reduce lock-in and get diversity in what's a very, very fast-moving space, we'll need to make sure that we're making decisions at every point in that journey that align to your unique needs, and maybe not just the generalization of those functions. The next is that we have to be extremely workload-centric in AI. So there is no concept here of broad generalization, in the sense that we just put pools of resources together and everything is good. It's a highly ineffective way of approaching AI. So instead, we need to be able to look at workloads and use cases and then define the exact infrastructural patterns that best allow us to service that, scale it across our organization, and do that in a cost-effective manner. And then the last is, while a lot of the focus in the current landscape is on the training of large generative and language models, the reality is that for the enterprise, the vast majority of us and you, frankly, will be way more focused on the concept of inference. How do we actually consume the models that we deploy across our ecosystem? And that consumption will be deeply tied to the location of that consumption and use. So we need to be able to put infrastructure and components and patterns in place that allow us to meet the user where they are and the type of workload where it needs to be deployed.
Hey everyone, Andy Sajous here. And so as Josh is kind of talking through this, I think there's some critical elements that he's touching on. And I think when you look at cloud and the hyperscalers, I think they're a great use case for failing, right? So when he talks about failing, and a lot of times when we meet with clients, it's failing fast, right? So when you look at cloud, I think when you look at the hyperscalers, they have flexible and elastic compute, which allows you to kind of really build out those use cases. But more importantly, it allows the organization to be rapid prototyping, meaning how do we test use cases? How do we identify use cases? But more importantly, let's take sensitized data or mass data, and more importantly, move it into a model where we can tune it, and more importantly, prove that value. And so when you look at cloud, I think cloud is a great platform to essentially build the use cases and ideate, and more importantly, prove out that value. It really becomes a platform to allow us to kind of test different architectures, test different services, in many cases, bring in services that you might not have available to you on the forefront, but then allow you to prove that out to build a business case to justify the build out of that within your own data center. Can you go next slide? But I think the one thing I want to talk through around from a cloud perspective is there is still challenges, right? And so when we think of cloud, I think the one thing we think about the flexibility, it does bring unpredictability, right? So many organizations that are looking to build out that POV model or that proof of value model for a specific use case, that dramatically affects the budget for organizations that are looking for a predictable budget. But more importantly, when you scale that over many POCs or many POVs, it does create cost constraints within the budget. Secondarily, I think from an ahead perspective, if you look at the organizations that we serve, specifically financial services, healthcare, manufacturing, there's a lot of regulatory and compliance needs in regards to what we do with the data. And so many organizations think from a perspective of, it may not make sense to move all my data to cloud. It may make sense to me build up my POV in a context where I can use masked or desensitized data. But more importantly, if I'm going to do this at scale, I do have to look at where my data resides from a regulatory perspective. And then lastly, when we look at performance needs, specifically pertaining to real-time or latency-sensitive applications, this does bring into context where I want my data to be close to the compute power. And that's just pure physics. So we're in most contexts, we're limited based on the bandwidth that for my connectivity to where my data resides. And I want to bring the compute power closer to where the data is going to live long-term. And so when you look at cloud's a great platform for POVing. It does help us rationalize some of the cost constraints as well as some of the data concerns that we see, which then brings in the complexity of maybe I need to bring some of this back on-prem. Next slide. So when we look at the hybrid cloud model, I would say let's break it down in kind of these three contexts. One is cloud. Our hyperscaler partners are really good at whatever we want to do, initial experimentation, rapid prototyping, bursty type workloads, or more importantly, use case and ideation. But then when we look at when we want to transform that model into a stable environment and scale that across the enterprise, we most likely want to bring that into our core data center. But then lastly, when we talk about some of the real-time complexities around latency-sensitive applications, or more importantly, we want to start leveraging some of the real-time use cases around Gen AI, we may want to look at edge deployments, where we want to bring that compute power closer to whether we're looking at medical devices or we're looking at energy grids, and we want the ability to do this in real time. that then puts in the use case around how do we look at edge as a component of this environment. And so when we break down hybrid cloud models, it's, I would say, these three core components that we're focusing on. Next slide.
I think that's a good lead in, Andy, for the reality that, over the last decade, I feel like we've spent a lot of time working with customers around hybrid cloud as a core component of their overall IT ecosystem. And at the end of the day, what we've continuously learned through that is that application disposition and application placement ultimately play a massive role in making sure that we align the right infrastructure. And what we're observing, at least so far in the AI space, is that it's no different. These are advanced workflows and intelligence-driven applications that ultimately have the same types of criticality, need, and placement requirements. So when we look at kind of what should be in private infrastructure versus what ultimately can be accessible or leveraged or maintained in public cloud, we really need to start looking at the factors of that application. How secure is the access requirement and the underlying data set that we're using to both build and infer against the model? How wide can we optimize versus how much do we need to generalize against the kind of funnel of things coming into our environment? How much actual customization and tuning do we need? Obviously, we maintain a greater level of control under platforms that we can operationalize or even build fit to purpose in this particular space. But the counterpoint there, obviously, is we can get into cloud resources, especially in scenarios where we have constrained supply chains, which has been a real challenge in the AI infrastructure ecosystem. We can get access to resources and functionality for our teams faster, right, in most circumstances in public cloud. Now, that flexibility, as Andy mentioned, and the availability of those resources that are constrained can come at a very significant cost. And much like any other application, if an application has significant downward elasticity, there are huge opportunities in cloud from cost optimization perspective. But what we see happening in the inference space is that these workloads only scale traditionally in one direction and that they scale upward in terms of scope. And the more use cases we put into those computational platforms, the greater the impact of that scaling over time. And the more predictable we can make that, the greater economies of scale and the greater consistency we have by being able to deploy that often in private infrastructure scenarios. And then the last piece of this, obviously, as Andy touched on, is really like, not only where does the data reside from the early phases, like how are we developing, thinking through our models and customization, but ultimately, like, where's the data coming into the environment that we need to leverage in order to decision against it? And that's going to play an incredibly critical role, especially in our edge environments. So kind of what do we see happening across our clients today? At Ahead, we really think about this as 3 Ps. We see organizations that are looking to leverage expert models and expertise in very narrow focuses. We call that kind of the product space, people that are working to essentially commercialize a specific aim around AI, whether that's generative or traditional ML and DL. And ultimately, organizations look to leverage those particular pieces as a service through their process. In the public space, this is where we see a lot of the what was B2C tools ultimately now being leveraged in B2B fashions through these same services. So this is where organizations are leveraging publicly available, publicly hosted models through privatized services, typically in either specific interfaces or directly through APIs. And then the last component is what we call private. And this is where we're leveraging things like open source models against our internal data sets and internal architectures in support of specific use cases, often tied to things like data gravity or data sensitivity, or frankly, just scale out and experimentation constraints. Or we see those kind of pieces being leveraged in cloud-based versions of these platforms as starting points, depending on where you kind of were in the trajectory of cloud maturity more broadly across your enterprise. So in that, we obviously have seen major platforms that try to make this easier to operationalize, from folks like Google in the form of Vertex, Bedrock from AWS, and even Fabric from Microsoft. And so the concept here is, where does the data live? What are you trying to do with it? What types of data exist across that? And then what are your aims, right? What are the use cases? And we actually build backwards from the type of application that's trying to be deployed based on where it ultimately needs to land. We see this kind of in that concept of experimentation that Andy was mentioning And the early days, we started to see a lot of what we would call like death by 1,000 pilots, where we didn't have a good functional understanding of like how to actually take a use case from good idea potentially to matrixed and prioritized across the organization to validated, evaluated, and ultimately capable of being deployed in a governed manner. And so when we look at this kind of concept of experiment, validate, integrate into your ecosystem, and then ultimately continue to monitor and enhance over time, we think of the dark blue areas as really keen components where that cloud experimentation is going to be an integral part of what you likely need to go do. And when we switch into that kind of light blue space, what we're saying there is we really need to start evaluating specifically how we're going to service that type of workload once it gets to scale across my enterprise. We thought we would shift and give you some real world examples of how this is actually manifesting across our customer base to make it more real. So in this particular example, we were working with a global automotive manufacturer to think through a very kind of what sounds simple, but ends up being incredibly complex kind of matrix of production optimization across a massive permutation of potential configurable options in only one vehicle class that they have. And in this particular scenario, they were focusing on the fact that there were 40,000 different permutations of that vehicle configuration that they could bring to market. And so they had this idea around how do we leverage an optimization algorithm to look at when we should manufacture which specific configurations, and then ultimately downstream from that, how do we align what we've produced in inventory to our dealer ecosystem in order to ensure that we have the lowest time on lot scenario for those vehicles that we've produced, and where are the equilibriums for that? But the reality is like this is a tough problem with a ton of potential need and change and transformation. And so it was very obvious from the very beginning of that we needed to start ideating and building against this in a cloud environment in order to see if the hypothesis that they had and the types of data that they needed ultimately became viable in that space. And as this has been rolling from kind of the proof of value construct, which ran for about an 8 to 12 week period in that environment, they're now starting to look at how does this ultimately get deployed down into the facility and into the plants. And in most situations for them globally, that will be against private infrastructural components as it's deployed. Andy, can you talk about one of our leading healthcare providers?
Yeah, of course. Thanks, Josh. And so when you look at one of our healthcare organizations that we partner with very closely, we had a couple of their data science team to speak at our healthcare summit back in April. They talked to this exact scenario, right? So they have an R&D team that's focused on solving clinical challenges. That leads a lot of their innovation in regards to they walk hospital floors and look for challenges that they can solve with AI. And when they spoke to our group specifically in the healthcare summit, they talked specifically about what we're talking about today is how do they take specific use cases? They do all the model training and tuning in public cloud. And when they go to scale out, they bring that back on-prem. And this is all because of some of the challenges they saw specifically when they went to go scale across 12 to 14 hospitals. And so when they think of from a consumption standpoint, a lot of the GPUs costs that they were consuming in public cloud exponentially grew out of control from a budget perspective. And so what they were looking to do was how do they take the same kind of infrastructure requirements that they have in the public cloud, and how do they replicate that back on-prem with not only dormant capacity existing in their data center, but also GPU capacity that they're leveraging in cloud. And so a lot of that was focused on how do we take the same kind of requirements we see, replicated that and built out an H100 NVIDIA cluster on-prem, and now it becomes cyclical. So as their R&D team travels throughout the organization to solve these unique challenges, they built a repeatable process around the way they POV. And then more importantly, when they decide that the business or the clinical groups want to move this into a system-wide initiative, then they bring it back on-prem into their GPU cluster. Next one.
And then in the last scenario, we're dealing with organizations that have challenges specifically around what we would call distributed intelligence needs. And this is a mix of diversity of locations, heavily globally distributed, or in this case, North American distributed, requiring real-time assessment of information that's inbound into these systems. So for this particular railroad operator, they were looking at a scenario where they wanted to place cameras to enable computer vision, so discriminative AI, not generative AI, across their rail structure. I think it was every 18 miles or so of rail. And the thought process is that they could use the camera and sensor information to determine things like track safety, weather conditions, and ultimately rail and derail risk scenarios across their footprint. And that required us to actually look at edge in a very significant way. It required us to look at things like modification to off-the-shelf equipment in order to meet their specific environmental, connectivity, and frankly, power delivery needs in these ultimately, many of which remote locations distributed across that footprint. And in this scenario, the cloud plays into this as well because the model development stages occur early in that experimentation point, but ultimately get deployed in a very localized fashion into those edge devices. And we see the same kind of pattern emerging in anyone that has a geographically distributed footprint. So we see it in manufacturing clients for things like visual inspection and production flow analysis. We see it in our retail customers that have many sites to thousands of sites in terms of things like shrinkage or loss prevention scenarios and self-checkout, as well as things like consumer and product flow. So edge is going to play an absolutely critical role, not in the development necessarily stage of AI, but absolutely critical in the deployment of that intelligence across that enterprise environment. And ultimately, whether it's a scenario where we need to rapidly think and discriminate against things in a cloud perspective around how we experiment and kind of look for opportunities and align good ideas to ultimate capabilities, the point here is that we need to create a consistent flywheel approach where we intake specific ideas around those use cases, analyze and aim to match those particular things with the business value potential, key KPIs, and what we would call success metrics for those particular use cases. And then we need to immediately be able to put that through a POV process and ultimate pipeline to be able to look for things like where are our data gaps, where are our data quality or accessibility challenges, how well do we align to the actual business ownership and business value creation mechanisms for that particular use case. And can we actually build both alignment, but also mechanisms to evaluate not just the deployment of it, but frankly, the use of it over time to ensure that we're continuously getting out of that particular AI use case and implementation exactly what we expected or better on the front end. So Andy, can you talk a little bit about how we've turned our kind of traditional understanding of the IT ecosystem and adapted that the way that we see our customers needing across this landscape, spanning from cloud to infrastructure?
Yeah, of course, Josh. And so when you look at our service portfolio, I think it directly correlates to the methodologies that we've always taken, right? So starting with, the visionary advisory elements, I think a lot of organizations are focused on what is their AI strategy, or how do they go about an AI hub, or providing governance and data governance around what they're doing. And so we have capabilities in-house to support that. But more importantly, when you look at kind of the two other elements highlighted, so in the green, you'll see the transformation, right? So how do we focus on the data engineering, some of the data analytics and data science that goes behind this, as well as services to support that? That's something that we've always done from our perspective. So not only do we leverage some of the cloud services that we talked about that are unique to some of the hyperscalers, but also how do we provide some of the capabilities that you're looking to build on-prem? And then lastly, when we look at the foundational elements, as we look at, for example, AI infrastructure, AI storage, InfiniBand networking, all of this plays into the way we want to support you enterprise-wide, including some of the edge AI elements that Josh was talking about. And at the end of the day, when you kind of look at kind of how we hover from, not only the foundational and the transformational elements, this, at the end of the day, is the hybrid cloud story that we've been talking to a lot of clients over the years. And it's just repeatable from an AI perspective. And so these are some of our offerings in this space. I think this is how we would approach it. We can meet you where you are. I think that's a key element, meaning we know a lot of organizations are deep into maybe the POV process, but are looking to build out infrastructure on-prem. We know many organizations are just starting off and looking to devise a strategy. But at the end of the day, we have offerings in the space to support you, and more importantly, can meet you where you are. And one thing I want to call out as we kind of talk through kind of the hybrid cloud architecture of AI, I think it's our OEM partnerships that allow us to be really, let's quote unquote nimble in the space. And so when we look at Dell, and the offerings with Dell and NVIDIA, I truly believe that we have the ability to build, and more importantly, size and architect around what you're looking to do. And so I know Josh hit a lot on the edge AI components. We have, custom integration facilities to support you there. As we talked about, how do we scale this enterprise wide, leveraging, smart NVIDIA GPU clusters within your data center. We have capabilities to do that there, as well as you're looking at services in the public cloud, and maybe you want to leverage NVIDIA DGX Cloud. Like we have capabilities to support you there. And I think that the good thing is our OEM partnerships in this space are very much representative of ways that we could, there's not one size fits all. I think we have the ability to really support you depending on what you're looking to do.
In Andy, I would just add, I think we think it's absolutely critical that we look for partners across this space that have the ability to bring us flexible but opinionated solutions that kind of both de-risk some of the efforts that we have here, but help us kind of mitigate some of the underlying decision-making requirements that ultimately allow us to focus more on, like, what are we trying to do with the AI workload, and less about the plumbing underneath. And I think the NVIDIA component of this, obviously, beyond the realities of its market leader approach on the GPU ecosystem, we really see this extending like far more into the software stack. Most organizations we walk into are far more familiar with core infrastructure adjacencies in this space than they are with the software platforms needed to make it real and to create portability from those initial cloud aspirations ultimately into their data centers for operationalizing, and even from an inference and lightweight architecture at the edge. So we think it's really a very combinatory effort of, can you select the right hardware portfolio that's flexible across your deployment modalities, but also make sure that we're aligning consistent platforms at the software layer that allow you to really take advantage of these things and accelerate your efforts. The reality, though, in this circumstance too, is that, while it's really exciting and there's obviously a ton of potential that we see coming behind this, it's not without significant challenges as we kind of maneuver through this transformation. The two things that we see kind of predominantly being major issues from an enterprise data center perspective are, one, we're just simply not prepared at the timescale changes of how much density uptick there's been through the inclusion of these particular infrastructure patterns. So traditionally, within like the last 5 years, an average rack within a data center was around 8K to 10 kW. When DGX kind of came online and ultimately HGX components of that platform, it's completely not uncommon for us to see in the 40 kilowatt range now in terms of pure density in single rack scenarios within our current data center footprints. But the reality is, Blackwell and next generation chip architectures come online, that 40 kilowatts is accelerating all the way up to 120 kilowatts in a single one rack footprint. And ultimately, that's going to be wildly improbable that we're going to be able to support that within our current DC infrastructure footprint and power envelope without making some substantial changes, inclusive of the way that we do heat removal ultimately from those environments. And that's why you're seeing a lot of the next generation components of that private infrastructure start to shift towards liquid cooling and direct to chip scenarios in support of these far denser heat loads. And
I think what Josh makes some critical points there. And I think what we bring to the table with Ahead's Foundry is our ability to provide you an end-to-end integrated solution where we've taken all that into account. So our engineering, specifically sitting in the Foundry group, has been focusing on not only liquid cooling options, some of the, obviously the power draw consumptions, as well as best practice reference architecture, aligning not only to our partners like Dell and NVIDIA, but ultimately thinking through a lot of the complexities that we've identified here, right? Thinking about the back-end networking architecture or the front-end Ethernet architecture. A lot of that drives our ability to be successful in this space. But what we want to make is simple and easy for our clients is to provide that end-to-end turnkey integrated solution where we're thinking all of that for you, right? So meaning allow us to do the engineering work behind this. Let's retrofit, obviously, best practice reference architecture in support of what you're looking to do. but more importantly, provide that end-to-end integrated experience where we're just dropping completely configured, pre-configured racks within your data center in support of your opportunities from an AI perspective. And Josh, can you hit the next slide? And so when you think about the foundry, which is located here in Libertyville, it's our ability to not only provide pre-configured deployment or deployed assets, whether we're looking to do pre-configuration on the networking or infrastructure side, complete rack integrations, so complete end-to-end wired complete rack, whether we're looking at storage, network, compute, as well as any customized or ruggedized infrastructure. Our ability to provide warehouse and kitting, so meaning we could warehouse and as well as track inventory, asset tag, all infrastructure within our facility, but more importantly, bring that through our organization to not only stage, but also global logistics. Our ability to ship that to 189 countries at a global level allows us to scale some of these capabilities pretty quickly, especially when we start talking about some of the edge AI use cases at a global level. And Josh, can you hit the next slide? And at the end of the day, from our custom integration side, where we're helping not only organizations around retail depot or edge compute, which is the use case that Josh gave you from a CSX standpoint, as well as embedded and appliance hardware, where we're manufacturing medical grade devices today. We can work with organizations that are looking to build a truly customized edge experience specifically for the use case that you're trying to drive. And so I know we focus a lot specifically on the initial data center infrastructure, but it's also our ability to navigate some of the edge computing requirements and the customization that goes into these types of devices, all through our foundry services. Josh, anything you want me to hit on that I might have glossed over?
No, I think you captured it. I think the reality is we don't see a lot of this that isn't going to require a substantial amount of kind of customization and kit management. And we're really looking at this and saying, how do we just make it generally easier and de-risked for you to be able to deploy the right type of infrastructure in the right location to serve the types of use cases you ultimately want to be able to host and provide. And at the end of the day, it's just, no one in the organization is going to care deeply about the infrastructure. They're going to care about the business value created through the deployment of these particular AI workloads. So we need to make that as easy and as competent as humanly possible.
Yep.
So I know we've talked a lot about what you need to do and why you need to do it, but let's talk about what the result of approaching that strategy is the right way. First of all, if we think about the data relationship into this ecosystem, our ability to make sure that we're putting the right things in the right spots gives us a lot better security posture and ultimate control over the way that data is being leveraged and ultimately where that data potentially goes as a side effect of that inference ecosystem. So it's really about, how do we maintain a better posture and ultimately better control across that landscape. The second one is the side effect of putting the right workloads in the right places and tailoring and optimizing across that entire hybrid environment is we get better cost optimization in our ability to serve those models up in a predictable, meaningful, and scalable way. And then the last is it allows us to absolutely tailor and marry the performance and scalability needs across your enterprise, all the way from small, single CPU, single GPU systems at the edge that are literally meant to deploy on a specific singular use case, all the way to very consolidated architectures for distributed inference in your data centers. And so the reality here is it gives us the best of both worlds. It gives that initial downward elasticity that we need in experimentation and fail fast modes, and it gives us the ability to deploy the right things in the right spots. And what we've learned across doing this with clients so far, and I will say it's still very much early days in this ecosystem and it's moving very, very quickly, but we would expect that these core concepts will persist even as the methods around how we get value out of AI continue to evolve and change. The first one is we need to understand the use case in order to build the right platforms. So that distribution is a side effect of what we're trying to accomplish, not necessarily an over-opinionation or affinity for what our teams feel in IT we're the most comfortable with in that space. Two is that we need to design a flexible infrastructure that marries to the lifecycle expectations of those particular needs. So we need to be able to look at how we focus on experimentation, how we focus on productization of those particular pieces, and then the distributions and modalities of scaling across that ecosystem. And then the last is, this is a partnership between IT and the business, in many ways deeper than we've ever needed to facilitate before. So it becomes incredibly critical that we can create visibility around what we're building and how it aligns to their specific needs and aims in a way that we can properly prioritize, develop, and deploy in direct alignment to where they see the most value. These are business-led, business-driven needs that ultimately shake out into pretty obvious infrastructure components if we do this the right way. So with that, we wanted to be able to take save time and take some questions from the audience. So Grace, did we have anything come in through the chat?
We have not yet. We'll give people a moment if they'd like to submit anything.
Okay. Well, maybe we take a minute to kind of cover off on a couple of things that we typically hear in these discussions, kind of in the early points of working with clients on their specific journeys. The first is really becomes a matter of like, well, it's great that we understand that we need to approach this as a hybrid environment. We get the relationship in our normal enterprise between cloud workloads and on-premise use cases and workloads. But how do we determine like what things should remain in the cloud after that experimentation phase versus things that ultimately need to move back on premise or into our edge environments? And I think like while this seems like a very critical question on the front end, the reality is like it absolutely depends. It really depends on the types of models that you intend to leverage and need hosting behind. So if you're building specific use cases primarily on public models, it may be very, very critical for you to align the rest of the systems into that same public model leveraging estate in order to make sure that we can effectively deploy and efficiently deploy across that ecosystem. In many circumstances, though, we're seeing things where the data component of ultimately what drives the use case viability really makes this decision for our clients, which is if we have IP sensitivity or we have substantial data gravity, or the like actual exfiltration of that data is coming from on-premise COTS applications and ecosystems, it may be far more practical for us to bring the compute to that specific data set than move the entire ecosystem up to take advantage of cloud resources. And edge environments typically are pretty obvious just on the basis of where the distributed intelligence points are and what the connectivity requirements and kind of data shipping mechanisms are back from that distributed environment. So Andy, can you touch on like maybe what we're seeing in terms of how we integrate across this ecosystem, or maybe like the types of tools that people are kind of considering as they try to create portability across the space?
Yeah, so I think when you think of from a hybrid cloud infrastructure perspective, I think as we talked about previously, I think networking is a huge focus, right? So I think as we talked about where data resides, and then more importantly, the architectures that go behind my hybrid cloud connectivity, I think that is truly important, especially when we talk about maybe organizations that are looking to still leave components of AI in the public cloud. Also, I think as we look at, for example, just our ability to navigate some of the data infrastructure side of it, right? So I think organizations that are looking to get a little more nimble around their data, I think we've seen some of the OEM partners that do this really well, as well as I think at the end of the day, I think as we drive more ability from an edge standpoint, I think a lot of that ability to provide management as well as edge compute management or even fleet management at that level is pretty important.
Sure. I think it's amplified too in no small part by the reality that most of these deployments will occur through containerized ecosystems. So a lot of the actual software delivery components involved across this do finally allow for consistent portability across those environments in ways that's been kind of more challenging in the traditional application estate if we're trying to make things containers versus deliver things natively across those kind of microservices architectures by default.
Sure.
And then I think that from a cost implication perspective, obviously to bring on a tremendous amount of parallel computing or accelerated computing capacity is no small endeavor. So what we're kind of thinking about here is you're really comparing some of the most expensive cloud infrastructure resources and bare metal componentry within that estate to kind of the long-term amortization or flexibility of how can we optimize and take advantage of other pieces in that private infrastructure. And I think the compute side obviously dominates a lot of that cost implication, but the storage side is also really, really critical. So if we think about the constraints around using these things effectively, we do need high throughput. We're typically talking about large amounts of information, and there are really practical, very cost-efficient ways to do that in many circumstances on premise that may be more difficult to synthesize in those cloud environments. So it's really a mix, right, based on what you're trying to do. But we think when you look at the kind of overall cost to serve, it's not ultimately that different. And frankly, it's actually driving downward. So the cost of inference, so per token rate over the last year in most of the really large public models has actually decreased 97%, which means it's not that the architectures behind them are all that much better, but the model efficiency and algorithmic efficiency behind them is dramatically improving. And so we'll be able to get more out of those investments and serve more use cases from the same types of infrastructure that we build initially to support our first set over time. And that's how we kind of look at it from a cost optimization perspective is as long as we can continue to improve on the number of things we're pushing into the environment, our cost to serve and our business value creation out of those environments will continue to improve. So Grace, any changes in the chat?
Yes. So I sent Andy over the questions that were asked.
Oh, I don't think I see it, Grace. Let's see. Oh, got it.
Okay, great.
No, maybe not.
Oh,
Here we go. All right, let's go first one, Josh. So it says, a lot of business and management are concerned about IP and the use of cloud. The data concerns, there seems to be data breaches every day. So any rebuttal to that one, Josh?
I don't know the rebuttal. I mean, I think the reality is that the cybersecurity ecosystem is extremely fragile and frankly, deeply concerning in terms of bad actors. I think the reality is a lot of the organizations that we work with that are really focused on data sets that contain highly sensitive information are typically the ones that are experimenting the least in cloud and building out kind of proactively the most on premise. So there's a kind of a direct correlation in my mind between the IP sensitivity of your data and the criticality of your data and ultimately the types of architectures or the proportions of architectures that you ultimately build. And so we kind of do see a lot of leverage around, well, what are you trying to do? How is that data classified? And then how do we use that to understand what we can leverage and where we can leverage it responsibly?
Josh, I have an interesting one that came in. So it says you have a slide that discusses AI considerations with products, public and private space. With regards to leveraging commercial platforms, quote unquote products, what have you normally seen these company recommend in terms of AI infrastructure?
So in many circumstances, we still see some of those products being deployed as SaaS architectures for clients. In situations where those unique ISVs have on-premise deployment requirements, and many of those are specifically like edge-oriented product implementations, we see them bring pretty consistent validated designs that we can then work against and align to kind of guarantee the types of performance or SLAs that the end consumer of that model ultimately aims to expect through the deployment in their ecosystem. So I think it does vary in terms of like what type and kind of the deployment methodology across it. But I would say SaaS still plays a significant role in the model delivery process.
And then Josh, there's one last question. So, and I think you hit on a little bit of this, but let's just go through it. So as you talk about the security risk of having data in and out of the cloud, what kinds of capabilities does a head have to encrypt and tokenize data at rest in motion to mitigate these risks?
So Good question. I think the reality is that we would leverage, I think to your point around network and storage subsystems earlier, Andy, we would work with our kind of core partners in that space to ensure that we can comply with those particular needs across that entire stack. So whether that's ensuring the right policy administration and controls are enabled in the hyperscaler of choice, or doing things like external key management, all sorts of potential things that we've been doing for a decade now in cloud to ensure those things are turned on, are properly reflected in the storage systems and network architectures on premise. By the way, most of the primary like high throughput storage providers, including things like PowerScale from Dell, certainly enable that encryption within their storage platforms. And then I think it's just about building the right kind of hybrid CXP and networks to support appropriate encryption and data protection as it traverses those networks between those environments. So I would just say it's a blended scenario, but it's really a carry forward of a lot of the embedded security functionality that exists in those estates that we've been working on for years, adapted for AI.
Yeah. All right. There's one last question just came in while you're answering. So what are Head's current Kubernetes operations platform software of choices?
So I think, we really see kind of a couple of things in this space. I would say, we have clients that are really focused on, kind of consuming, like buying a very prescriptive architecture through something like an NVAIE, so NVIDIA AI Enterprise Suite, which comes with embedded containerization capabilities and Kubernetes orchestration within that platform. I'd say that we see other customers looking at platforms like OpenShift for AI as a mechanism to deliver that orchestration and Kubernetes management layer. And then we have really, like, I would say the very far end of AI maturity, where customers are really leveraging open source tools and putting those things together in creative ways to try to build competitive edge. And in that space, I think we still see a significant amount of traditional Kubernetes and things like Kubeflow as a major component of the kind of pipelines in that particular estate.
That's great. Yeah, Grace, I think that's all the questions I see on the main chat.
Yes, you are correct.
Yeah.
Well, then with that, obviously we want to thank everyone for spending about 50 minutes with us today. We appreciate your attendance and look forward, obviously reach out to your Ahead representative with any additional questions. We would love to be able to partner with you and your teams as you kind of continue to take on this AI journey. We hope we can do it together. And we look forward to you joining us for session 3 in mid-November, where we'll close the loop on ultimately what do we need to do to integrate this into our enterprise ecosystem. So with that, thank you very much.